Welcome, my dear student. We learn the topic transference number or transport number and factors affecting the transport number. When the current is passed through the electrolyte solution, then the ions of the electrolyte get migrated. Thus, they carry the current through the solution. The movement of ions through the solution is a movement of a charge, and the hence there is a passage of the current. The various electrolytes that can be used for that purpose, for example, HCl, NaCl, KCl, potassium nitrate, lithium chloride, silver nitrate, barium chloride, potassium sulfate, sodium acetate, sodium sulfate, and so on. In a electrolyte solution, different ions move with different velocities under the potential gradient. Same potential gradient hence will involve the different transfer of a charge and hence a different current carrying capacity. Thus, the transference number of the electrolyte solution depends upon the amount of current carried by the ion, that will be depends on its velocity. The transfer number is defined as the fraction of the total current carried by the given type of ion. The type of ion, that is a cation or the anion, either in the solution. The transport number of the cation is equal to T plus upon I, T minus is equal to transport number of anion, T minus is equal to I minus divided by I. The I is a total current that can be passed through the solution. I is equal to I plus I minus. For example, we take the sodium chloride. The I for Na plus and I for the Cl minus. I is the total current passed through the solution. The T plus is a fraction of total current carried by the cation, and the current carried by the cation is divided by total current passing through the solution. T minus is the current carried by the, that is the fraction of the current carried by the anion, I is equal to the current carried by the anion upon the total current passed through the solution, electrolyte solution. Means the transport number is also related to the velocity of the ion, velocity of the cation mu plus, and the velocity of anion is mu minus. Then T plus is equal to mu plus or U plus divided by U plus U minus. T minus is equal to U minus divided by the U plus U minus. The current carried by an ion is proportional to its ionic conductance. The current carried by the cation is proportional to the lambda plus, that is the ionic conductance of a cation. The current carried by the anion is proportional to the lambda minus, that is the ionic conductance for the anion. The total current carried by both the ions, cation and anion, is proportional to it, and it is the both the for the ions the proportional to lambda plus lambda minus. T plus transport number of the cation is equal to the current carried by the cation divided by the total current carried by cation and anion. T minus is equal to current carried by the anion divided by total current carried by the cation and anion. Means T plus is equal to ionic conductance of a cation divided by ionic conductance of the cation plus ionic conductance of anion. Then the lambda plus divided by lambda infinity or lambda 0. Lambda plus divided by lambda infinity for T plus, and for T minus, lambda minus divided by lambda infinity. Means lambda infinity means there is a ionic conductance at infinite dilution, or the ionic conductance at a zero concentration. Means there is a zero concentration means there is a very dilute electrolyte solution. Then the ionic mobility U or mu, then ionic mobility is equal to ionic conductance divided by Faraday. Means ionic mobility means there is a velocity with which the ions moves in the solution. Means the ionic mobility is equal to ionic conductance divided by 96500 coulombs. The velocity of ionic mobility, that is decreases with increasing the concentration for the strong electrolytes. The factors affecting the transport number. The factors affecting the transport number are: first, that is the concentration; second, nature of electrolyte; third, temperature; fourth, hydration; fifth, complex ion formation. First, there is a concentration. Concentration of the electrolyte, which is increases, then the number of ions present in the solution increases. Means there is a increase in interionic forces of attraction, and thereby decreasing the velocity of the ion. Thus, the transport number of the ion will decrease with increase in concentration. The transport number, it reaches a limiting value at infinite dilution. The variation of transport number with a concentration is represented by the equation T is equal to T0 minus A square root of C, where T is the transport number, T0, or we take T infinity. T infinity is a transport number of the at infinite dilution. A is a constant and C is a concentration. We plot the graph of the T versus the constant square root of C. Then T is a transport number which is along the y-axis plotted, and the concentration of C is along the x-axis. Then A is a constant. Then the y is equal to mx plus c we equation consider. Then this, there is a straight line graph with a negative slope which corresponds to constant A. The t is equal to t infinity minus a negative slope, and intercept on the y-axis, it is a corresponds to t0 or the t infinity. T infinity or t0. T0, it is the transport number of the cation or anion at infinite dilution. The second, that is the nature of the electrolyte. It is related to the this nature of the co-ions. Means the transport number of a cation depends on its co-anion and vice versa. Means the cation, which is a cation having the transport number which depends on the anion which is associated with it. Thus, the transport number of ion is a different in a different electrolyte solution. The transport number of NaCl and HCl, if we consider it, the Cl minus and the Na plus, H plus and Cl minus, then transport number of Cl minus in NaCl is a 0.61, and the in HCl it is a 0.70. The transport number of then the Na is a 0.39, and the transport number of the H plus is a 0.83. Means the H plus ion, which has a higher speed, means there is a higher velocity, and they have the more transport number. Much the Cl minus have the transport number is less in case of HCl than the NaCl. Another that is a factor, that is a temperature which affects, that is a increase in temperature increase the velocity of the ion. Hence the transport number should increase with increase in temperature. With increase in temperature, the transport number of all the ions which approaches the limiting value of 0.5, and the temperature which acts as a leveler for the velocity of the ions. The transport number, it is greater than zero point 0.5 decrease with temperature. If the value of the transport number is smaller than 0 0.5, increase with increasing temperature. Means there is a transport number of the ion that can be maintained 0.5 by increasing or decreasing its value. The greater than value 0.5, which decreases with the temperature, and smaller than 0.5, it is increased with the increasing temperature. The transport number that must be fractional, and it transport number of two ions, cations and anions, that is 1. Next, that is the hydration. Hydration, it is related to the size of the ion. The size of ion increases with the velocity of the ion. Also, will the velocity decreases with increasing size, decreasing the transport number of that. The solution which is get hydrated in water, then the size get increased. The size of hydrated ion increases. The hydrated complex ion get formed and retards the speed of the ion in the electrolyte solution. The transport number of the ion, that time there should be a decreases. The chlorides of the lithium, sodium, potassium are considered, that is of the alkali metal ions. The lithium ion is the smallest and the lightest of these three ions. The ionic size of the lithium, if we consider, then lithium ion should travel fastest because it is a small and hence have a highest transport number. But it is not true. It is a reverse, and the lithium ion is in a small size and high charge density. Therefore, it attracts a large number of water dipoles. Means there is a lithium ion has a strong electric field around it, and it has a greater number of water molecules are attracted towards it. And in case of potassium, the potassium which has the large size and the very low charge density, so the water molecules attracts in a small numbers, that is the attracts only small number of water dipoles. So the lithium ions has the greater hydration. Degree of hydration is a maximum for the lithium, and the speed of that lithium ion is a maximum. The degree of hydration is a minimum in case of potassium, and potassium ion has a maximum more speed and the more transport number. The degree of hydration of sodium plus ion is the lies between the them. The transport number of the lithium ion is less because the lithium ion get hydrated. The speed of the lithium ion is less, that is mobility is also less, transport number also less because of hydration. Another, that is the complex ion formation, or it is a complexation. Means there is also effect of concentration. Sometimes the transport number of the ion decreases with increasing concentration and it becomes abnormal. That is the transport number becomes 0. negative or more than 1 also. The transport number of cation, anion together should be 1 as they are fractions. We know. It is found that the concentration has a marked effect on only on the transport number of cadmium ions in a cadmium iodide. Cd plus 2 ion with the CdI2 solution. The value decreases from the 0.449 to about the 0.5 at low concentration, 0.005 molar, to almost 0 at a higher concentration, that is a 0.5 molar. Means a higher concentration, the value of transport number is 0, and at low concentration it is 0.5. This is due to the complex ion formation at the higher concentration. Low concentration, CdI2, it gives Cd plus 2 and twice I minus. These Cd plus 2 ions migrated towards the cathode, that is the negative electrode, and at a higher concentration, CdI2 plus twice I minus, it gives the CdI4 complex, CdI4 twice minus complex, and this anion complex travels towards the anode. The transporting cadmium towards the anode instead of a cathode. This decreases the transport number of the cadmium plus 2. When cadmium plus 2 and CdI4 twice minus complex ion carry equal electricity in opposite direction, the transport number of Cd plus ion becomes 0. At higher concentration, the formation of the complex ion is so high that more cadmium is transported to the anode than the cathode. As a result, the transport number of Cd ion becomes a negative. Means what? The transport number of cadmium ions, that is a negative, and the iodide ions transport number becomes greater than 1. Thus, the behavior of transport number is abnormal. That is the abnormal transport number. For example, the Fe plus 2 ion with FeCN6 4 minus solution, that is a FeCN6 4 minus, the complex ion formation, it also shows the abnormal behavior. Here the cadmium ion complex, cadmium I4 twice minus, the anion travels towards the anode instead of cathode. Means there is a abnormal behavior and there is a negative transport is observed. So example, other example that will be explained, that is Fe plus 2 ion in a FeCN6 complex. Thank you.